Right now, inside every single one of your cells, there are literally billions of microscopic engines. And they're spinning faster than a jet engine, powering pretty much everything that makes you, you. But here's the real kicker. Where on earth did they come from?
And this quote just nails the problem perfectly. When you get a good look at this molecular machine, it's called ATP synthesis, it doesn't just look complicated, it looks designed. It has a rotor, a stator, catalytic heads, it has all the parts. It looks for all the world like a machine that someone deliberately built.
So, that leads us to the central question we're tackling here. If evolution is a blind process, right? No plan, no blueprint, how could it possibly crank out something that just screams intentional engineering? That question can really stop you in your tracks. But trust me, the answer is even more incredible than the machine itself.
Okay, so to find that answer, we kind of have to fight our own intuition. Our brains see a machine, and we immediately think there has to be a machine maker. But what if the design isn't a blueprint? What if it's a pattern that just naturally emerges from the fundamental laws of physics?
This is the absolute key. Evolution doesn't work by just throwing a box of parts in the air and hoping a perfect little turbine just happens to land, fully assembled. No way. It works through tiny, gradual changes. And here's the catch. Every single little step has to provide some kind of immediate advantage. So ATP synthase isn't some crazy lucky accident. It's the inevitable result of billions of years of thermodynamic pressure pushing life to get more and more efficient.
So to really understand this engine, first we have to understand its fuel. And we're not talking about gasoline or electricity from a wall socket here. The power source for nearly all life is something way more fundamental. It's something that exists anywhere you have a boundary and a difference. It's called electrochemical potential. The easiest way to think about it is like a dam. A cell works really hard to pump protons, which are just hydrogen ions, to one side of a membrane. It builds up this incredible pressure. And that difference in both electrical charge and concentration is basically a tiny stored battery that the cell can tap into. This gradient, well, it's the universal energy currency that all life spends just to stay in the game.
But why protons? Life has all sorts of other ions it could use. Sodium, potassium, calcium, you name it. So why did life almost universally settle on the humble proton as its go-to energy carrier? Well, turns out it wasn't a historical accident at all. The answer comes straight from the rulebook of physics.
And this really gets to the heart of it. You could say life didn't really choose protons. Physics practically forced its hand. Protons are just the perfect tool for the job. They're tiny and super efficient. They store energy in two ways at once, as an electrical charge and a pH difference. They play really nicely with water, which is, kind of important. And critically, the very chemical reactions that release energy from food are almost perfectly suited to pumping them. It's a match made in thermodynamic heaven.
So if physics chose the fuel, did it also discover the engine? This is where we have to really shift our thinking away from the idea of engineering and more towards how nature just stumbles upon stable, efficient patterns for channeling energy.
This chart illustrates the difference perfectly. Human engineers have foresight. We use a blueprint. Evolution has neither. It's just a process of tinkering. It's constrained by physics, and it only keeps the changes that offer an immediate benefit. It isn't building towards a final product. It's just preserving whatever works, one tiny step at a time. The turbine wasn't designed. It was discovered by the process of selection.
And what about that spinning motion? It feels so advanced, so much like a human invention. But it turns out that at the nanoscale, where everything is this chaotic storm of jiggling molecules, rotation is actually one of the most efficient, low-friction ways to convert one kind of energy into another. It's not some exotic leap of genius. It's a natural solution that physics just leaves lying around for life to find.
The parts for this engine didn't just appear out of thin air. Nope, they were repurposed. They were cobbled together from older, simpler molecular parts that were already doing other useful jobs, like pumping ions across a membrane. Think of it like evolutionary recycling. A part that used energy to pump ions out could, over millions of years, get tweaked and flipped around to let ions flow in to create energy. Each little step was a small, functional improvement.
And this all builds to something truly profound. The fact that this system is so effective and so deeply rooted in the laws of physics, well, it raises an incredible question. If this is how life works here, is it possible this is how life works everywhere?
The first big piece of evidence is right here on Earth. ATP synthase is in almost everything that's alive, from the simplest bacterium to the neurons in your brain. It's ancient. It existed long before the major domains of life split apart. That staggering universality suggests this wasn't just a fluke. Once this energy system was discovered, it became the non-negotiable foundation for all complex life that followed.
And here's a truly mind-bending idea. What if life didn't even have to invent this energy source at all? On the early Earth, deep-sea alkaline hydrothermal vents would have naturally created proton gradients. You'd have alkaline vent water mixing with more acidic ocean water. That's a free battery, just sitting there. Early life could have simply emerged inside the tiny pores of these vents and plugged right into this pre-existing power grid. And listen, this isn't just a story about ancient Earth. The same conditions, water, rock, and chemical gradients, very likely exist right now elsewhere in our own solar system. On moons like Jupiter's Europa or Saturn's Enceladus, we think there are hydrothermal vents on the floors of their subsurface oceans, creating the exact same kind of energy gradients that might just be sparking life as we speak.
And this brings us to our final and maybe most important insight. This tiny invisible turbine isn't just about making cellular fuel. It's the engine that unlocks the door to all of biological complexity, including, when you take it all the way, consciousness itself.
It's a simple phrase, but it's incredibly profound. Without a massive surplus of energy, life has to stay simple. It just doesn't have the budget to do anything fancy. But with the incredible efficiency of systems like ATP synthase, especially after they were gobbled up by our ancestors and became mitochondria, life suddenly had energy to burn. It could afford bigger genomes, complex multicellular bodies, and eventually, nervous systems.
So it all starts here, with the simple difference across a boundary, a raw potential for energy, created by the laws of physics themselves.
And that potential has to go somewhere. It creates a current, a flow, an unstoppable stream of energy that can be harnessed.
And that's what life is. It's a process that learns to channel that flow, turning it into chemical work, into metabolism.
And that work builds things. It creates order from chaos. It builds stable structures capable of sustaining and replicating themselves.
And after billions of years of that process, that structure becomes complex enough to actually turn back and contemplate the very flow of energy that made its own existence possible.
And this leaves us with a final, provocative thought. Maybe life isn't some miraculous one-off fluke. Maybe it's a tendency that's written into the fabric of the universe itself. And maybe, on any world, in any galaxy, where you have those three ingredients, energy gradients, chemistry, and time, the same story begins to unfold, all powered by the quiet, constant turning of an invisible turbine.